Hello, it's Keith here, and this is lesson 20 of the simple series of my Z80 programming tutorials in which we make a simple example that does a task in a single assembly file. Today we're going to be making a simple joystick reading routine. We're effectively extending our bitmap example. We got a smiley on the screen before, you can see it above me just here, and now we can move it around. If I select the right window and I press my cursor keys, you can see we can move our smiley around the screen, but we can't move it off the screen. We're limited to the screen area. So we've got some checking of the position of the cursor, of the coordinates of the object, and we're moving it around with the gamepad, but I'm using my cursor keys because I'm using an emulator, of course. Now, the sprite you can see here is actually a tile bitmap. So we're using the tile map, and that's going to limit us to moving in 8x8 blocks, which is a little bit limiting, but as I often say, if you're a beginner and you're writing your first game and this is the kind of thing you're looking to get started with, then I think you want to stick to the simple thing of using the tile map for your graphics and worry about using sprites later, because sprites add a lot more limitations. Number on screen, number on a single line, things like that. They're harder to get working with. So get started using your tile map. I'm sure you can create some kind of really nice game with that. And then once you become more confident, you can always convert it to sprites like I did with YQuest, because that started using the tile map and was then upgraded to use sprites later on. So, just because you start with tiles doesn't mean that's where you're going to be limited to. Now, as I say, the example today we're using is based on the simple series, the bitmap example, so I'm not going to be rushing over the code that has not really changed since then. I'll go over it very quickly, but I'm not going to go into the details because it would be just repeating that entire lesson. The main thing we're going to be focusing on is the Joypad reading today, and we do that with primarily port DC. Now, the majority of the settings, at least for player one, it's all the same for the Mastersystem and the GameGear. GameGear has a smaller screen, but that just means we need to change our coordinates a bit. The Mastersystem had up, down, left, right, and fire. The GameGear added a start button, but of course the Mastersystem does also have a second player controls, but we're not going to be reading those second player controls today. So to read in the player one, we just need to use port DC, and that will give us access to the two fires, up, down, left, and right. So we'll get all of those. If we want player 2, we would use also bits 6 and 7 of ports DC. We would then use port DD for the other options. And there's a few other things in there that we don't really need. Things like the light gun as well. Now, the GameGear start button is actually held in port 0. There is one other button that I do want to quickly discuss because I didn't use it before, but the pause button on the Mastersystem is not read in through any of these ports at all. It actually works in a completely different way. It actually causes a non-maskable interrupt, so a call to address 66 in our ROM cartridge. So you would need to put a handler there to read in the pause button, and if pause is pressed twice, 2 fires to that maskable interrupt would occur. It doesn't keep happening while pause is pressed or anything. So that's just something to note there. So that's the theory of how we're going to read in our joystick. It's super simple in our code though. Let's go over to that code right now and let's take a look. Okay, so here is our code today. So we're going to be going over this and we're going to look at seeing how that example that you can see up there works and how we get our smiley moving around the screen. Okay, so the way this example works, first of all, we've defined some memory and we're going to use 2 bytes of memory here in the C000 range. That's the RAM of the cartridge of the system, and we're using that for the X and Y position of the sprite. But what we're also doing is storing an old position of the sprite in C0, 12 and 13 here. So we've got 10 and 11 for the main position and 12 and 13 for the last position. And that's just the way this code works. What it does is it stores a backup of the old position of the sprite, moves the position, checks if the new position's okay, and then resets it if it's not. Now, what we've got next is we've got a start of our cartridge here, and there's just a bunch of returns because we're not using any kind of interrupt handler. You will notice here that there's one at 66, which would be where that pause button will fire to, but the pause button is going to do nothing today. We've then got the start of our code here, lots of stuff relating to setting up the screen, transferring our bitmap data. We're effectively using 2 bitmaps today. We're defining a smiley and we're using one of the other unused tiles as a blank to remove the smiley from the screen. So here's our bitmap data. It's 16 colors, of course, and it's the same smiley that we used last time. So that's what we're using for our graphics. We have to transfer them into VRAM here. We've got this define tiles routine. We looked at that in the simple series. So again, I'm not going to go over it again today. If you don't know how it works, please see the bitmap example for the Mastersystem within the simple series. Now here is the start of our code today, the new code. So what we're doing here is we're setting the X and Y position of the player to 0 at the start. So that's got us a nice starting position. And then we're jumping to this start draw routine. Now this is here. And the reason we're doing this is that the main loop here, this infinite loop here, is actually checking the input and it's waiting until a key is pressed. So if we jumped straight to that at the start, then we'd never show the starting position of the smiley and the user would be presented with a blank screen and probably think the game didn't work. So that's why we're bypassing this infinite loop on the first run. And the way we read in during that infinite loop is just we read in a byte from port DC, as I said before. Port DC is basically all of the player 1 controls. We're only using player 1 here, so that's all we're reading from in this case. And we're just checking all of the bits and seeing if any of the directions has been pressed, and until one has, we're just jumping back here, repeatedly infinite looping there. Now when one is pressed, we're going to go into our main loop here and we're backing up the key that was pressed, and we're then backing up the X and Y position of the player sprite. And we're going to use those later if we need to restore the old position of the player sprite. Then what we do is we run this routine called blank player. Let's take a look at that now. So the blank player routine and the draw player routines are basically a remake of the original simple series example where we drew a simple sprite to the screen using the tile map. All we've done is we've changed it. The blank player routine will show tile 129. The draw player routine will show tile 128, and 128 is our smiley, and 128.9 is an unused tile, and we're just calculating the VRAM address within the tile map, same routine as before, and then we are just writing 2 bytes. The first byte is the tile number and the second byte is a 0 in this case. That is things like the options relating to the palette and the flipping, which we don't need for this example. So that's how we're blanking the player and also how we're drawing the player to the screen. What we do next is we are going to check all of the bits for each direction. So bit 0 is up, and if that is a 1 then the up direction isn't pressed, but if it's a 0 then that direction is pressed. And what we do if the direction pressed is pressed, then we just alter the X and Y coordinates, and the X and Y coordinates of the sprite are now in B and C here. So we're just decreasing C going up the screen there. Here we're increasing C going down the screen and checking for that down key. Here we're checking for the left key and going left. Here we're checking for the right key. And if I just scroll down a little bit, then we're going right here. So this has updated the player position, and then we save the new player position back to the X and Y values in our RAM. These are RAM definitions, of course. Okay, so now what we need to do is we need to check and see if the player has gone off the screen. Now, if you see here, of course, we can't go off any of the directions of the screen. And there is a little bit of a trick we're kind of employing in this, if we just go over here. So if we imagine that this is our screen here. So here is our screen, and this is our x-axis, and this is our y-axis. Now, here is our 0, 0 coordinate, and our screen on the Master System at least is 32 by 24. Now our sprite could be, for example, here. Let's imagine that is a nicely drawn sprite and not an awfully scribbled blob. Now as our sprite moves around the screen, it'll have various coordinates, and here the x coordinate will be 0, and here the x coordinate will be 32. Well, what happens when the x coordinate goes below 0? Well, if you think of our calculator, when we've got a value like 2 and we subtract 1, then we'll go down progressively until we get to 0. But when we go below 0, we'll wrap around and we'll effectively end up back at 255. FF, of course, is 255 here. So when our sprite goes into negative values, it actually effectively ends up as a very high value, and it will end up effectively as a value of something like 255 or 254 or something. So rather than checking for values below 0, we actually just need to check for values greater than 32, and that will effectively check the very low values as well. So that's what we're going to be doing in our code here. So here we're checking the X boundary, and depending on the GameGear or the Master System, we're using different coordinates. So the GameGear screen is 20 wide and the Master System's 32. If we are below that, then our position is okay. Otherwise, we're going to run a routine called player reset. And then we're going to do the same for the Y position. We're going to check the Y position, and if we've gone out of range again, we're going to reset. Here's our play reset routine, and all it does is it loads in the old position and writes it back to the new position, setting the sprite back to the position it was because the player has effectively gone out of bounds. Then what we do is we run our draw player routine. We've got a simple little delay, and then we jump back to our infinite loop where we read in the input again and do the whole thing once more time. So, I mean, it's a very simple little program. It's just a really basic example to show you how to get a screen set up, get a very basic graphic onto the screen, and then how to move it around and do some simple input reading. And this isn't the best example in the world, don't get me wrong, I'm not trying to pretend it is. It's just hopefully enough to let you get started quickly, and hopefully now you can have a play around and make something far better. I'm sure you can. So there we go. Of course, as always, you can go to my website and download the source code for today's example and also the build scripts if you don't have them, so you can hopefully build this up and get started really quickly. That's the idea of this. If you like what you've seen, please hit the like button and subscribe. And also, if you're interested, you can buy my book from Amazon. It's called Learn Multi-Platform Assembly with Chibi Akumas. It covers Z80, 650, 268,000, 8086 and ARM. And so hopefully it will help you out with your programming. It's got a beginner's guide which covers basic terminology, and also chapters on each of the processors discussing all of the instruction set and other things you will need to know. So if you want to support this channel, that's a great way to do it. Anyway, I hope you've enjoyed this today. Thanks for watching, and goodbye.